Now we can move to the next session. Okay, so I guess everyone knows him, Harsh Bothra, who is posting the challenge, posting the learning every day. Okay, so can we have a big round of applause for the Harsh Bothra to present his talk on tail of chaining bugs for the account takeover?
All right. Hello, everyone. Today I'll be talking about tale of chaining bugs for account takeovers. So, quick introduction. I work as an application security engineer, or you can say tries at H1. So, a lot of folks, I have handled your reports, and today I'm going to give you some tips and like how can you convert your low-hanging fruits into some really, dollar-giving bugs. I am a core lead pen tester at Cobalt, and I also manage community and product growth with Acto. I have authored 2 books. You might have known me from Learn 65 or Security Explained series. I do sometimes write blogs or create mind maps and content. Okay. So, quick agenda for today would be, to discuss about account takeover and leaving you with a simple question if it's a vulnerability or an impact. Then some ignored vulnerability, or I would say low-hanging fruits, which usually gets closed as informative or not applicable or something like that, and how you can utilize those vulnerabilities to basically convert them into some high-paying vulnerabilities like account takeovers. Okay, and that's gonna all about it. So I have created a quick poll on Twitter. You can go to Harshbothra underscore and quickly answer whether it's a vulnerability class or impact. Like, what do you think? What are account takeovers? A vulnerability itself or an impact? Okay. Okay, so these are some of the ignored vulnerabilities, or mostly I would say are closed as informative or low, like open redirection, CRLF injection, GraphQL introspection query, missing content security policies or HTTP security headers, host header injection, rate limiting on API fuzzing paths. For example, you have something api.something.com and fuzzing is missing over there. Like people say that we can do directed brute forcing and stuff like that, but you can do a lot of things. Lack of server-side validation, external or I would say like, DNS interaction or something like that, prototype pollution. If you are into mobile pen testing, you might be knowing about deep links. So deep link misconfiguration. A lot of applications are using SAML, SSO, so auth misconfiguration, and at the end HTML injection. So these are a few like ignored, or I would say like low-hanging bugs, which generally in bug bounty space are closed as informative, not applicables or low. Okay. So today I'll be picking up a few topics. I'll take 4 of the bugs that I have found are one of like most paying bugs in account takeover category, and they are like pretty logical and easy to find. Okay, so these are the 4 bugs: GraphQL introspection to account takeover, hosted injection to account takeover, CRLF, which was leading to cross-site scripting again to account takeover, and at last open redirection to account takeover. Okay. So going with the first one, so introspection query is usually like giving you a schema information about GraphQL, and most of the application, it's accessible as an unauthenticated user as well, right? So as soon as a lot of you might have reported on BugCrowd, H1 or other platforms, and you see that it's getting close informative saying that it's not leaking anything sensitive, right? But always go and visualize that particular query. So in this case, what I did is like the application was allowing any unauthenticated user to basically run the introspection queries, informative again. Now, after digging and basically visualizing, you can create graph of these queries and see like how various relationships and links are built on operations. I found very interesting operation: get user ID by email and generate auth token using email. Okay, this definitely caught the eye over there. And then authenticated attacker. Like I'll basically sign up to the application, log in as the attacker account, and I'll simply perform any authenticate action to reach the GraphQL endpoint. Once I am at GraphQL endpoint, I'll manipulate the query to basically run the get user ID by email query. Now I have the user's UUID. Emails are easy to guess. You can obviously create a list and brute force. So I now have the UUID, which is one of the like complicated scenarios in bug bounty. You will see that from tries that, hey, how would you go and enumerate the UUIDs, right? Now, once I have UUID, now I can go ahead and try to get the auth token of the victim user. Now, here come another problem is that it won't throw me the token directly. So the next part was the logical manipulation, or you would say parameter pollution. What I simply did is like on that operation, I simply add attacker ID comma victim ID, and it throwed me the victim's auth token. Now I can access the victim session and perform the queries. Story is still like not ended over here. using that victim sword token, I was able to change their email address and then reset the password, and it led to full account takeover. Okay, so initially the severity was informative when I reported this bug, and then we escalated because it was more of like on the curiosity part, and it ended up in the critical. It was a private program, and it was a 5-digit bounty. Okay. So the next one is host header injection on email change. So a lot of time we hear that we do password reset poisoning. We find host header injection on endpoints like, reset password or change password like of that, and it's an account takeover. That's a common vulnerability. This was interesting one. This was from one of the pen tests that I did. So the application was sharing the same code base. So for example, you can either sign up as an external user. So for example, harsh@gmail.com as well as harsh@company.com. So from the company.com, you will have access to an additional dashboard that allows you to reset the password for all the users. Now, I simply tried host header injection on almost all the endpoints, terribly failed. I then run collaborator everywhere, and on this email change endpoint, I found that I can do the host header injection. So what I did is simply I tried to change my external user harsh@gmail.com to harsh@company.com. The harsh@company.com guy received that email. He clicked on that. I received the OAuth token because I had the accounts. Obviously, that was for the demo purpose, right? So once I was able to steal the confirmation token, I was able to escalate my privilege to that internal dashboard. And as soon as I would able to change almost everybody's password, and that was a mass account takeover again from informative scenarios to critical, right? So the next one is CRLF to cross-site scripting that led to account takeover. Now, a lot of times we find cookie-based injections, cross-site scripting, which is closed as self-accesses. Okay, in this scenario, there was a self-cross-site scripting via non-existing cookie parameters. So I always say that first the cookies has a lot of value. So like anything, like let's say random equals to cross-site scripting payload, and it will go and execute. Okay. Now, first the application further and found that there was a CRLF injection through double encoding. Basically, like you have to double encode the CRLF sequence. Now, use this CRLF sequence injection into a non-existing cookie parameter and created a payload something like, something.com, then the CRLF injection payload, which is double encoded, value equals to cookie colon XSS payload. Okay. Now, this is a pure reflected XSS payload. Anybody will go, any authenticated, unauthenticated user will go to this particular link and it will execute into cross-site scripting. It's still a medium severity issue. Now, further, I was curious enough and noticed that the OAuth token, the JWT token was passed as a cookie parameter as well as the authorization header, right? In that scenario, I was able to basically create a session hijacking POC, hijack the user session, change their email, reset the password, and again, full account takeover. Initially, it was informative self-cross-site scripting, and you can chain it to something critical. Okay. So the last one is the open redirection to account takeover. A lot of you might be thinking like, the triers ask that, open redirection issues are closed until you can demonstrate the further security impact. So this is what you can do next time, that how you can go and, demonstrate the further impact. Now, so this particular application, it had multiple sub-applications. So for example, you have quite a big set of application, then you can go to, let's say, module A, module B, module C. And whenever you click on a specific module or sub-application, it will generate an auth token to basically authenticate you to that sub-application. Okay. Now, in that redirection parameter, I was able to find an open redirection. Simply, the attacker was able to access the sub-application because I set this particular parameter to, let's say, harsh.com. It redirected the token along with it. I was able to extract the token and access the sub-applications. Now, it was not critical, it was high because I cannot still access the main application. That's a different story that I was able to pre-escalate later. So it was high, and the company awarded in a 3-digit bounty. Okay. There are some other interesting scenarios as well, like HTML injection to AWS metadata leading to AWS account takeover. So for example, you have a template generation functionality, for example, in a website builder or something like that, where the HTML code can be processed on the server side, or they are basically taking your HTML code, rendering it to generate some, let's say, form or preview pages. You can iframe AWS metadata API if they are not secure and perform a complete AWS account takeover. In the mobile phones, you can use insecure deep links to basically perform account takeover. Password reset poisoning is again a classical example. Mass assignment is like, you might have seen something like admin equals to true in the response, and you can add it into your request saying admin equals to true, and your low privilege user become admin user, something like that. So Then you can perform IDOR on multiple places to perform account takeover. So lack of server-side validation in email during registration leading to account takeover. This is a very interesting scenario. So for example, there is a public sign-up, but that allows sign-up only via company email. Let's say harsh@company.com. Now, what you can do if the server-side validation is missing is you can capture the request in your burp suite or any Zap proxy or anything and simply change harsh@company.com to, let's say, harsh@gmail.com, and if there is no server-side validation, you will be able to access the internal database, right? So that was my first blog on this vulnerability, and they pay really well for these scenarios because they are mostly like logical bugs, seems very easy to find, and they are pretty, high reward paying because most of the time the application owners, they care about their users and their data. So my target in bug bounties or pen testing is always first to focus on like how you can target their logical or business logic kind of things, how you can steal their data, and then I jump to the server side attacks. So I have some next plans, like I'll be launching an updated mind map on different techniques for account takeover, and there will be a more, stretched version of this talk where I'll be explaining like 20 kind of different scenarios on account takeover. A quick summary is like a crux of this particular talk is to dig deeper. Don't stop whenever you find a low-hanging vulnerability. If you have found, let's say, open redirection or a self-access or something like that, give that vulnerability some time, go back to the application, find how you can chain different scenarios, and at the end of the day, how you can add value to the program team, how you can give them something really critical or sensitive to, patch for. And they really pay well, and trust me, chaining is something that is always helpful. Thank you folks for listening to me, and that's all. If you have any questions, feel free to ask.
I just have a simple question related to GraphQL. A subject has its own mind map, and each mind map has its own methodology. So what kind of methodology I should keep while reading GraphQL?
Okay, so GraphQL is really interesting and fun to play. Every time you, so what I do when I test GraphQL is I first go and check if I can access the introspection queries as an unauthenticated user, because it will give me a very good view about the schema and everything, right? Now, I'll visualize it basically. Okay, after visualization, I usually go and search for some interesting operations. For example, in application, what happens, sometimes you don't see the operations in use, but in the schema, you will see those operations. So these are more of like, undocumented operations, on the APIs, you see undocumented endpoints, right? So look for those specific operations and now see that how you can utilize those operations and again, perform some interesting logical attacks over there. So I have written a blog on GraphQL attacks. You can find it on Cobalt's website. So maybe you can go and have a read about it. And if you have any doubt, any further, you can reach out to me on Twitter or LinkedIn and we can discuss as well.
Okay, so my second question is kind of like similar one. If you have to put GraphQL into simple words, what would be?
I am still like not able to.
So second question is similar like to first one. So if you have to put simply GraphQL into some simple words, what would be? Sir, do you understand Hindi? GraphQL को अगर आपने सिंपल वर्ड्स में एक्सप्लेन करना हो एक लिटरल न्यूबी को, तो आप क्या बोलेंगे उसको? ये क्या टेक्नोलॉजी है?
So I would say कि इन लोगों ने थोड़ा सा what they did is basically they compressed all the API endpoint into a simple thing, right? It's like a one-stop shop for everything. It's like your supermart where come to one place and you will get each and everything. So this is, I guess, a simple definition to GraphQL, I would say. Instead of going through all those 1,000 requests, you now have to care about securing only one endpoint, securing only one operation type, securing only one mutation type, right? So it's like you need not to have a very big variety of shops and keep 10 watch guards or watchmen over there. Keep one supermart, keep one watchman, and that's all. So it saves a lot of time for developers. It's easy for you to add new operations, new mutation each and every time. And if you have one endpoint secured, it does a job like pretty well. I guess it answers your questions, right? Thank you.
Any other questions?
Hi Harsh, my name is Sridhang Divakar. First of all, thank you so much. It was an amazing talk. My question to you is that as you mentioned about the CRLF and XSS, nowadays it is very rare to find CRLF vulnerability. So do you use any particular word list for that, or how do you find those?
See, again, the point is like, obviously CRLF is rare, but it's like not totally disappeared, right? So usually what I do is I have my own fuzz list created. I use simple burp intruder to fuzz it. So you can fuzz it, and again, it's more about trying your luck and see if some application is having that particular vulnerability open or not. It's possible like it might not have, and it's possible it might have. So obviously it's obsolete because of new frameworks and each and everything. But again, fuzz it and see like if it is getting reflected. Like simply set a value, and one thing you can also do is intrude it and also set a match and replace rule in burp suite and see if your response is getting reflected in the burp suite, and that's how you can detect if this is vulnerable to CRLF.
So you have a custom word list. You don't use a particular word list.
Yeah, because obviously like most of the bug bounty hunters and pen testers have their own word list,
Okay.
because at the end of the day you have to stand out of the crowd, so you have to work on your own kind of methods and techniques to go about finding the bugs.
Okay. Thank you.
Yep.
All right, we are good to move forward. Thank you so much, Harsh, for the very informative session. Can we have a big round of applause for the amazing session?